Hello, this is Math with Beth, and we are now going to do solving quadratics using factoring. So the key to using factoring to solve a quadratic is to make sure you have everything on one side before you start, which means you will always have a 0 on the other side. So if that's not happening, you're going to make that happen first. But number one is good to go. So now you just need to remember your rules of factoring. So you take out a greatest common factor first, if you can. If you can't, and it looks like this, you're probably going to be able to go straight to your two parentheses, figure out what numbers multiply to -4 and add up to -3. So that would be -4 and +1. Once you have factored it completely, then you take each factor separately and set each one of those equal to 0 and then solve them separately. So in this case, we would add the 4. In this case, we would subtract the 1. So these are our solutions, which are also our roots and are also our zeros and are also our x-intercepts. Those are all the same thing. So number 2, same idea. We're ready to start because we have our 0 over there. But because of that 2 in front, we need to use something like the AC method. So I have a video on factoring with a being greater than 1. So that's what I'm going to do here. So 2 times -3 gives me -6. So I'm going to think about factors of -6 that would get me to this -1 in the middle. And that is -3 and +2. So now I'm going to use those two numbers to rewrite this problem. And now I'm going to solve it with factoring with grouping. So with grouping, we kind of separate this into 2 separate groups and take out as much as we can from each group. So in this case, I can take out an x. From the second group, there is no greatest common factor. So when that happens, you just put a +1 out front. And now if the parentheses match, which they do, you can take out one of the parentheses. And then the other one comes from what was left in front of each one. So that's the x plus 1. So the factoring was harder on this one if you're not comfortable with the AC method. So you can watch a video on that. But now I can set each of my factors equal to 0 and solve. So I'm going to subtract 3 here. Add the 3 and then divide by 2. Hopefully you're fine with this type of algebra because I'm running out of room. And then for this one, we're just going to subtract 1. So my 2 zeros this time are 2/3 and -1. For number 3, there's another way you could do this with square roots, but since the directions say to factor, I'm just going to do it with factoring. So this is a difference of 2 squares. So with a difference of 2 squares, you separate them by saying what times what gets you that first one, what times what would get you the second term, make 1 plus and 1 minus. So this is a difference of squares. If you need to watch a video on that, I have one of those. So now I set each of these equal to 0 and finish this by solving. So here I would subtract 5 and divide by 2. Here I am adding the 5 and dividing by 2. So those are my 2 answers. Number 4, step 1, this one finally does not look the way we need it to start factoring. So I need to get this 20 to come over. So I'm going to subtract the 20. That's step 1. Step 2, I can tell there is a greatest common factor. So I'm going to take something out before I get started. I think 2 is the largest number I can take out. So I'm going to take out a 2. And now I need to factor using the AC method. So I'm going to do the 3 times the -10 off on the side. Think about factors of -30 that could get me to that 15. It's not going to be 3 and 10 because they need to be positive and negative, but 15 and -2 would do it. So I'm going to ignore that 2 out front for a second, and I'm going to rewrite the problem using the 15 and the -2. And now I'm going to do grouping. So what can I take out of these two? 3m. What could I take out of these two? I could take a 2 out, but then they'd both be negative. So I'm going to take out a -2. So hopefully things will match, which they do. So final answer as far as the factoring is m plus 5 and 3m minus 2. Don't forget that 2 out front is really still there. But at the end, if there's just a number by itself out front, setting that equal to 0 is going to be pointless because 2 equaling 0 makes no sense. So if there's a number by itself, you can just ignore it. If there was an x with it, you would set x equal to 0. So let me make sure you see that's not an x. So I'm just ignoring the 2 because it was a number all by itself. Set both of these equal to 0 and solve. So m equals -5. And hopefully you're okay with me doing this in my head. I'm going to add the 2 and divide by 3. So that would give me 2/3. Okay, let's do 2 more just for practice. This one is ready to go, but step 1, take out a greatest common factor. Now, looking at the parentheses, I notice I have a difference of squares, so I can go further. And now I have factored as much as I can. There is an x with this, so I am not going to ignore it. I'm going to set that equal to 0, as well as the other 2 factors. In this one, I would divide by 3, which gives me 0 as my answer, which is fine. Here, I would subtract 3. Here, I would add 3. So we ended up with 3 zeros, or x-intercepts, in this one. And finally, number 6, not ready to start. So let me subtract that 8x over, so I have my 0. Now take out any common factor. And then in this case, after taking out the greatest common factor, which was 4x, I can't do anything else. So I'm done factoring. So I'm going to set these 2 factors equal to 0 and solve. So x equals 0 and x equals 2. If you like having steps, here are the steps for doing what I just did. So for solving by factoring, you get everything on one side, which means you have it equal 0. Take out a GCF if there is one, factor it completely, and then set each of the factors equal to 0 and solve. I hope that helped. See you next time.